melanocyte to melanoma. Melanocytes are cells that produce melanin, a brown-black pigment that determines the color of the skin, hair, and eyes in humans. It helps to guard against the damaging effects of the sun. In the skin, melanocytes are positioned at the epidermal-dermal junction, appearing as rounded cell bodies with long irregular extensions called dendrites. The formation of melanin occurs in the cell body, in an intracytoplasmic membrane-bound organelle called the melanosome. Next, the melanosome is transported by microtubules toward the surface of the melanocyte to a neighboring keratinocyte. Melanosomes are then released into the matrix of the cytoplasm in the keratinocyte and accumulate in the supranuclear region of the cytoplasm, thereby protecting the nuclei of dividing cells from the damaging effects of the sun. Several factors such as heritable predisposition and genetic mutations increase the risk of malignant melanoma. Ultraviolet UV radiation, such as that emitted by the sun, is directly absorbed by DNA and is a major risk factor for all types of skin cancer, including malignant melanoma. When UV radiation is absorbed by a double bond in a thymine base, the double bond opens, allowing the base to react with nearby molecules. If a UV-modified thymine base is adjacent to another thymine base on the same DNA strand, the two molecules can form a thymine dimer as a result of covalent bonding. The reaction most often involves the formation of two new bonds between neighboring bases, yielding a four-membered ring. The structural consequences of a UV-induced reaction include local distortions in the helix and a kinking in the DNA strand. If UV-related damage is not corrected by molecular repair mechanisms, DNA transcription and replication are blocked, and genetic information may be permanently mutated. Genetic mutations in melanocytes are associated with histologic changes along a continuum that may culminate in invasive malignancy. The transition from a normal melanocyte to metastatic melanoma may involve several histologic intermediates, including atypical dysplastic nevus of varying stages of severity, or melanoma in situ, and invasive melanoma. Indeed, melanomas diagnosed and treated during a radial growth phase have been shown to have an excellent prognosis. Currently, there is no cure for late-stage melanoma. As a result, early detection plays a critical role in reducing melanoma morbidity and mortality. New diagnostic tools to complement the visual examination of lesions, especially early-stage melanoma and borderline lesions, and those that lack the classic appearance of melanoma, could significantly enhance the detection process.
Anything that's something you've not noticed before, and it's caught your attention. It's caught your attention for some reason. Or anything that you've had that seems to be changing. It's bigger, starting to bleed, crust, any mold or pigment lesion that has regular borders or indication that fungus is very dark fungus in its life. Those are things that you should have looked at and say it's very simple to look at something and say that's worse or not. As someone who's trained, it's something that we obviously is a very simple procedure done in the office, very discomfort. And we know this, this is a problem. It's better to do a number of biopsies and have negative results than have one go on and get worse. I can't tell you how many people I've seen, how many men I've seen say because of white and
And for people that are worried about pain, they put a little, basically lidocaine, basically Novocaine on the spot. It takes care of that, right?
It's a pain-free little thing. It's always a nuisance. It's always, urban position. Going, biggest concern is this type of problem. Sure, discomfort.
Kind of like a paper cut.
I think it's better to know yes or no versus like something